Hello everyone! Welcome to Advanced Pastry and Confections. Today we're going to be talking about the sweet science. As some of you may know, this course is based off of my book of the same name. The purpose of this book was to teach advanced pastry techniques to home cooks, because in the professional world there's so much that goes into making pastries and confections that it can get very complicated. But at home, if you've got a good foundation, there's really not that much you need to know. So the idea was to take all of the techniques from the professional world and simplify them down to just the most important bits that will make a big difference for you at home. In this class, we'll be covering 7 different techniques that I think are essential for any home cook to know, and each technique is represented by one of the chapters in the book. So today, we're going to be starting with Chapter 1, Understanding Sugar. So why should you care about sugar? Well, sugar is an ingredient that most people just kind of use without thinking about it too much, because, let us face it, it's pretty easy to use. You just sprinkle it on top of something and then you stir it in until it dissolves. But the thing is, when you start to understand more about the properties of sugar and how they change when you combine them with other ingredients, it makes your life so much easier. Because instead of just learning a bunch of random recipes, you learn a few basic principles, and then you can apply those principles to any recipe, which means you can come up with your own recipes and modify existing ones to fit whatever situation you're in. And that is such a useful skill to have. One of the first things you need to know about sugar is that not all sugars are created equal. And I know that sounds kind of weird because after all, isn't sugar just sugar? No, actually, they're very different. So the first thing we're going to do is look at the molecular structure of the different sugars and then see how that affects the properties of each one. The way that sugars are classified is by how many molecules they're made up of. So we have monosaccharides, which are single sugar molecules. We have disaccharides, which are 2 sugar molecules combined together. And then we have oligosaccharides, which are 3 or more sugar molecules combined together. So one example of a monosaccharide is glucose. That's a sugar molecule that our bodies use for fuel. It's basically what our cells run on. Another example of a monosaccharide is fructose, which is the main sugar found in fruit. And a third example is galactose, which isn't found in nature as a single sugar, but it is found as part of a disaccharide called lactose, which is milk sugar. Disaccharides are formed when 2 monosaccharides combine together through a reaction called condensation. During this process, water gets removed and the remaining electrons get shared between the 2 molecules. So, an example of a disaccharid is sucrose, which is table sugar. This is formed when you combine glucose and fructose together. And another example of a disaccharid is lactose, which is formed when you combine glucose and galactose. And finally, oligosaccharides are formed when 3 or more monosaccharides combine together. An example of an oligosaccharide is raffinose, which is found in beans and other vegetables. So now that we have a basic understanding of the structure of these sugars, let's talk about some of the properties that they exhibit. One property that we're going to look at is melting point. Now, remember how I said that when these sugars combine through condensation, they form bonds between the molecules? Well, the strength of those bonds is related to the melting point of the sugar. So the more bonds that are formed, the stronger the bonds become, and the higher the melting point is going to be. So looking at the examples that we talked about earlier, glucose and fructose both melt around 180 degrees Celsius. Sucrose melts at a slightly higher temperature, around 186 degrees Celsius. And raffinose, which has more sugar molecules combined together, has a melting point of around 204 degrees Celsius. Another property that we're going to look at is solubility. This is how well a sugar will dissolve in a liquid like water. So the general rule is that the smaller the sugar molecules are, the more soluble they're going to be. So when it comes to our examples, fructose and glucose are the most soluble because they're the smallest. Then sucrose is next, and then raffinose is the least soluble because it's the biggest. And a third property we're going to look at is hygroscopicity. And this is how well a sugar attracts water molecules to itself. So for example, if you leave a container of sugar out in the air, eventually it's going to absorb water from the air, and it's going to turn into a hard brick. Well, the more polar the sugar molecules are, the more water molecules they're going to attract, and the faster that process will happen. So looking at our examples again, glucose and fructose are the most hydrophilic, because they have a lot of polar groups on the molecule. So they'll attract a lot of water and they'll turn into hard bricks pretty fast. Sucrose is less hydrophilic than those two because it doesn't have as many polar groups, so it won't attract as much water. And finally, raffinose is the least hydrophilic, because it's a pretty big molecule and it has fewer polar groups relative to its size, so it won't attract as much water as the others. Now, you might be wondering why it matters to know this stuff. Well, it matters because it allows us to predict how different sugars are going to behave in different situations. So for example, if you're baking a cake and the recipe calls for granulated sugar, you could probably use either white or brown sugar and it would turn out fine. But if you were using powdered sugar, it would be a very different story, because powdered sugar has a very low melting point, and it's also extremely hydrophilic. So if you were to use it in a cake, it would end up being very dense and heavy, and it would not have any of that nice airy texture that you want in a cake. Okay, so that was a lot of information to take in. So let's go ahead and take a break. Alright, welcome back. So far, we've learned about the different types of sugars, and we've learned about some of their physical properties. But the reason that sugar is so important in pastry is because of the chemical reactions that it can undergo. So that's what we're going to talk about now. When sugar is heated in the presence of water, it can undergo a series of reactions that ultimately result in the formation of a brown substance called caramel. The first step in this reaction is the formation of a compound called glucose-1-phosphate. And when this molecule forms, it triggers a chain reaction that results in the formation of hundreds of different compounds. Some of these compounds are volatile and they contribute to the aroma of caramel. Others are non-volatile and they contribute to the color and the flavor. And if you stop the reaction at the right point, you can actually use these reaction products to your advantage. So for example, if you stop the reaction early on, you end up with a product called glucose syrup. And this syrup has a very low melting point. So if you were to use it in a candy recipe, it would allow you to make very chewy candies, like caramels. But if you were to let the reaction go further, you end up with a product that has a very high melting point. And that product is called invert sugar. And this is because during the reaction, water is lost and the resulting syrup has a very high boiling point. So if you were to use this in a candy recipe, you would end up with very hard candies like lollipops. Alright, that brings us to the end of the first chapter and the beginning of the second chapter, which is mastering butter. So if you'd like to learn more about butter, go ahead and click that link right there. Thanks for watching, and I'll see you next time.